Over the last couple weeks, I've been working with the Firestore database and Angular Fire version 5. While these changes are mostly positive, there are a number of important issues and caveats that I wanted to share with pro members in this video. What I'm going to do is build my own database service that wraps Angular Firestore and provides additional functionality as well as reduce the amount of code needed to perform basic tasks. This code is just experimental, but I want to give you some ideas on how you can simplify your life when building apps with Angular and Firestore. Let's go into our custom Firestore service and we'll import Angular Firestore as well as the document and collection types. And then we're going to create our own custom type called collection predicate, which either takes a string or an Angular Firestore collection. You'll see in the upcoming code this will allow us to retrieve objects or collections with just a single string or an Angular Fire reference, which can greatly simplify your code as we'll see later. The capital T you see here is a TypeScript generic, and that just allows us to use our own custom interfaces on the objects returned from these helper functions that we're going to create. And we'll also go ahead and create a custom type here for the document as well. Then the next thing we'll do is add the Angular Firestore service into our constructor here. Then we're going to create a couple methods that wrap the Angular Fire collection and document methods that return a reference. The reason I'm doing this is so this service can be used as a drop-in replacement for Angular Fire. The only difference is that we can pass either a string or an existing reference to this function. So if we pass it a string, it's going to return an Angular Fire collection reference, and if it is already a reference, then it'll just return that reference. So we're going to go ahead and do this for both the collection and document. So at this point, this isn't very powerful, but you're going to see how this can be used to create really concise helper functions here in the upcoming steps. And if the capital T's are throwing you off everywhere, check out the TypeScript generics documentation for additional information on how to use generics. So one of the big changes with Angular Fire 2 was that the reference is decoupled from the observable data. But sometimes I just want an observable without having to make the reference explicitly. So I'm creating a doc method here with a $sign, and it's going to return an observable by just specifying a string or optionally a reference. So we can do that by first returning the reference from the method we had created previously, and then we'll call snapshot changes and map it down to the data payload. This is exactly what's happening under the hood of the main Angular Fire library. So we'll do the same exact thing here for collections. The only difference is we'll also have the option to pass a query function, so you can still send the query to Firestore. And when we type the observable, it's going to be an array of whatever type interface that we pass it. So again, we'll call snapshot changes and then just map it down to the data payload. And to return it as a custom type, we do as t after the payload has been mapped. Now that we have this done, let's see how it can dramatically reduce the amount of code needed in our components. I'm going to import Angular Firestore just for comparison, and then also our Firestore service. Then I'll create a custom item interface just to show you how we can strong type our return values from these functions. Then I'll set up a couple variables here in the component, just one for the reference and another one for the observable data. First, I'll show you how we would make a query for some observable data using just the regular Angular Fire library, and then I'll compare it to our custom service. In Angular Fire 2, we first make a reference to the data that we want, which in this case will just be the items. Then we have to set a separate variable and call reference value changes to get the observable. Now let's compare this to our custom service. All we have to do to get the observable is call the collection $sign method, and it does all this with about 60% less code. And it's still strong typed to the items interface, so we don't lose any of the TypeScript benefits that Angular Fire offers. So to display the data, we can just loop over it using ng4 in the HTML, just like any other observable. I've added an items collection to Firestore with each item just having a single property on it. Then on the front end, when we loop over the observable, we get the item content back as expected. So now I'm going to go back to the Firestore service and create another helper function that can return a collection with all of the document IDs included. This is a very common task when you want to query a collection and then query a specific document inside that collection. So if you were going to do this in Angular Fire directly, you'd call snapshot changes, and then you'd map the payload down to the data, and then add an additional ID property to the object that gets mapped. This is a lot of work for a simple task of just returning the IDs with the collection. So this method here will abstract away 90% of the code required to do this. So now if we use it in the component, first we'll look at the Angular Fire method. This is how it would look if you did it directly through the Angular Fire 2 API. Our custom service makes this way easier. We just call collection with IDs with the string of the collection that we want, and we're good to go. You don't have to worry about making the reference or doing any of that tedious mapping. To verify that it works, we'll go ahead and print out the ID here in the component. And if we refresh the page, we get the IDs back for each item as expected. The next caveat that I want to point out is that Firestore documents have no ordering by default. That means you need at least one property to order your collections by. I'm going to address this by adding a timestamp to every update or create operation that happens in Firestore. To create consistent timestamps, you need to get the server value from Firebase. So we'll go ahead and get that with field value server timestamp. The next step is to create our own custom set method. This is going to take an Angular Fire document or string and also a data argument. We can grab the Angular Fire reference and then we'll call set on it, but instead of just passing it the data, we'll also pass it an updated at and created at attribute. I've also created similar helpers for all the other write operations, but you can get that in the full code in the lesson on the website. So let's go into the component and see how this could be used. If we were using Angular Firestore directly, we would call the document reference and then say set data. With our service method, we can instead call dbSet and then pass it the reference that we want to set along with the data. Again, the reference could be a string or an existing Angular Fire document, so you have some flexibility there. If we go ahead and run this method on the front end, you can see it adds another item to our list. Then let's see how it looks in Firestore. The way I've structured these helpers is that the created at timestamp only gets updated when the document's first created, and updated at changes anytime that the update method is called. Another cool part about Firestore is that you can save data as the geopoint type. It will give you consistent validation and formatting of geolocation data. So we can get this object by calling Firebase, Firestore, and the geopoint class, then pass it a latitude and longitude argument. Once we have an instance of the geopoint class, we can just pass it to any one of our Firestore update methods. So when defining the data, we'll set it as the location, and then we'll call db geopoint with the coordinates that we want to set. So now if we send this data through the front end and then go to Firestore, we can see it gets formatted as the geopoint type. That can be really useful if you're building a map location-based app. And the last thing I want to look at for now is document references. The reference data type is similar to a foreign key in a SQL database. It allows you to reference one document from another document. The problem is that if you try to use this data in your HTML, you're going to run into errors because this data needs to be returned as an observable, which it's not by default in Angular Fire 2. There are different ways to approach this, but what I'm going to do now is create an Angular pipe. It will convert the reference into an observable so it can just be unwrapped directly in the HTML. I'm calling this the doc pipe, and it will take the Firestore service in its constructor. And we want it to return an observable, and it can do that because every reference has a path on it, and our doc method from the service can return an observable just from a single string path. So we can just call that method, and the pipe will automatically convert the reference to an observable. So in this example, our item has a user reference, which is completely unusable in the HTML by itself, but if we call the doc pipe, that converts it to an observable, which we can then call the async pipe on. And if we just want a single attribute from it, we'll go ahead and wrap it in parentheses and then call the user's username. In the app, it'll first load the item document and then the user document right after that. So that's just a few advanced concepts in Angular Fire 2 with Firestore, but this is just barely scratching the surface. If you have any questions, please reach out on Slack, and then look forward to a bunch more content in the near future about Firestore. Thanks for watching, and I'll see you next time.